All right, this video is just a few more examples again of transforming functions. Identifying what the parent function is first is always a great idea. Then identifying how it's going to be transformed, what's happening to the parent function to make it into the new function, such as our functions h of x here and q of x over here on the right. And then we'll also talk about the graphs and how to write in function notation. So first of all, let's think about this function at the left. Again, the thing that's going to govern the shape, the reason that the graph down below already has a V shape on it, is that absolute value, right here, that absolute value of x is going to govern what shape we're going to make. The big change, again, is that 3 in front of it. So the first thing we want to do is, again, identify our parent function. Our parent function for this function is that f of x, we'll call it that, again, our parent function f of x, is going to be just the absolute value of x. So you'll notice again on the graph, that's what this function is. It's that V shape going up and out from the origin there. Right? 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2. You get the idea. Now the major change, though, is I want to multiply all of those values. Note the 3 is on the outside. It's happening again after the function. So it's going to be a vertical change because it's going to happen to the y values. And it's times 3, so we're going to stretch, right, by 3. So everything's going to be 3 times taller. Or for the same points that I would plug in, notice what happens. Instead of 1, 1, well, the absolute value of 1 would have been 1, but times 3 is now up here. The absolute value of 2 was 2, but times 3, again, it's going to be up here at 6. So all of my points, all my y values of my points are 3 times larger. And you'll notice that, again, negative 1 became 1, well, times 3. 2 becomes 2 times 3. And really those other points would move as well, but we're going to be off our graph. So all we really need to graph, right, are the points we can see. Now our graph looks much narrower, but notice we changed the y values as we were calculating. That calculation happened after we had already found our absolute value, after our y values were sort of already in place from the parent function. So we changed our y values. We definitely vertically stretched by 3. When we talk about writing it a function notation, the idea was, again, h of x, our original function, was equal to f of x, right, our absolute value, but times 3 outside the function. So that's how I would write that in function notation. Now let's picture the one over here at the right. Notice the major idea there, the reason we get this sort of curve as we do on the graph, is that that's a square root function. So again, our parent function this time, f of x equals the square root of x. The only change, again, inside, we notice that negative. Again, it's inside the function, which means it's happening before, right, before we take the square root, which means it's happening as a horizontal change. So a horizontal, when we put a negative on or we multiply by negative 1, all of our values reflect, right? So this is going to be a horizontal reflection. And if you want to be very specific, if we reflect things horizontally, well, we're going to reflect them horizontally over that y-axis, right? Positives become negatives over the y-axis. So it's a horizontal reflection, or basically a reflection over the y-axis, which means we're changing the x values. Well, that makes sense. If we plugged in 1, previously the square root of 1 was 1, but now if I plug in 1, the square root of negative 1 wouldn't exist, right? We don't exist to the right side. Positive numbers are going to give us all imaginary answers, unless I plug in a number like negative 1. Negative 1, tack on that extra negative, right, is going to become positive 1, and we end up getting a point over here. Negative 4, tack on the negative, and then square root would be a 2, and we basically get a graph heading out to that left side, right? Looks just like the original one, only now instead of going to the right, our graph is traveling to the left. Our domain just switched around, right? Instead of traveling right, being greater than or equal to 0, now our new domain, technically, is that x is less than or equal to 0. So again, good things to note there. Finally, again, we need to write this in function notation to satisfy those directions at the bottom. Well, the big idea is, if again, if this is q of x, right, it's going to be equal to f of x, the square root function, only before we took f of x, we have that negative inside, so we're going to say it's f of negative x. We took out the x that was inside f of x, and we replaced it, right, with a negative x. I hope that, again, helps you with transformations of functions. If you have any questions about that, make sure you talk to your teacher. Otherwise, have a great day.